Welcome to Aman Water, where every drop counts. In a previous video, we showed you the entire journey of drinking water, from the river or dam all the way to your tap. But this time, we're zooming in on the technical details, step by step, because every link in the chain deserves attention. Each step will be its own video, a complete series to truly understand how raw water is transformed into drinking water.
Yes, we're diving deep. One episode per step, one topic at a time.
And we're starting with coagulation and flocculation, one of the very first stages of water treatment. Its purpose is to group together invisible impurities so that they can later be settled or filtered out. And to do that, you need a bit of science, a bit of finesse, and some well-chosen molecules. When people think of water treatment, they often imagine filtration or disinfection, making water clean. But before that, there's a major problem. Raw water contains impurities so fine that you can't filter them directly or let them settle. They're too small, too light, and on top of that, they repel each other.
Like tiny negative magnets. They float, they slip past, they refuse to stick. Impossible to catch them.
These impurities are called colloids, clays, organic particles, iron, or manganese in suspension. They're electrically charged and can stay suspended for hours, even days. So before removing them, you first have to break that stability, remove their charge. And that's exactly what coagulation does. Coagulation is the art of making those tiny particles stop floating on their own and start gathering together. How? By adding a coagulant, a chemical that neutralizes the electrical charges of the colloids.
It's like stripping off their electric armor so they can become sticky, not glamorous, but very effective.
The most common coagulant is aluminum sulfate, but you can also find ferric chloride, iron-based, or even natural coagulants like moringa seed extracts. Once added to the water, the coagulant dissolves and releases positive ions, such as Al-cubed. These ions bind to the negatively charged particles, creating unstable microprecipitates. It's a fast reaction. That's why a rapid mixer is used to spread the product evenly throughout the water. But be careful, the dosage must be correct, the pH suitable, usually between 6 and 7 for aluminum, and the contact time short, a few seconds to a minute.
Otherwise, coagulation fails, and if it fails, the rest of the treatment collapses. No flocs, no settling, no clear water.
Once the electrical charges are neutralized and the particles begin to stick together, we move on to flocculation. Its goal? To help those small clusters grow gradually until they form visible, heavy, compact flocs that can easily be removed.
It's like the particles dancing together, first by pairs, then in groups of 4, 10, 100, and finally, all dropping together to the bottom of the basin.
To do that, we use slow and gentle stirring in a tank called a flocculator. Unlike the rapid mixing used for coagulation, flocculation takes longer, and the stirring must be gentle. Too strong and the flocs break. Too weak and they don't form. Often, the flocculation basin is divided into several compartments, with progressively slower mixing in each one, what we call a decreasing G profile.
Speed 1, Speed 2, Speed 3. We make the flocs dance, but softly.
Sometimes, to strengthen floc formation, we add a flocculant, a long, sticky polymer that helps bind particles together. The result? Solid, stable flocs ready to settle. Now that we've seen the principle, let's see how it works in practice. In a drinking water treatment plant, coagulation and flocculation usually happen one after the other in a precise sequence. Raw water first enters a rapid mixing chamber where the coagulant is injected, either with a mechanical mixer or a high-energy jet. The contact is brief but essential. Then the water flows into a flocculation basin, often divided into 3 or 4 compartments. Each zone has slower and slower stirring to let the flocs grow without breaking. At this stage, a flocculant can also be added, especially if the water has little natural organic matter or if the flocs are too fragile. Everything is controlled: pH, injection rate, temperature, even the paddle speed. And behind all this, an operator ensures that everything stays within parameters.
A poorly dosed coagulant, and bam, nothing works anymore.
A good coagulation flocculation process is the key to clarity. If it fails, the next steps, sedimentation and filtration, have to compensate, which is rarely good news. So, what do we take away from this? Coagulation neutralizes fine, light particles. Flocculation helps them group gently into large, heavy, settleable flocks.
They're an inseparable duo. Without them, the water stays turbid, and the entire treatment chain is unbalanced.
And now, grab a glass of water and stay hydrated. If you're into this topic, don't forget to subscribe, hit the bell, and come with us to explore the world of water.